Okay, so today's notes are on solving radical equations, specifically square root, and then a few other different radical equations, and our language objective is to use the correct terminology to describe that process. We've done a lot of simplifying expressions, but now we're going to actually jump into equations. So this is sort of the next step in that chain of understanding. So I'm going to jump in with examples because I think we have most of the background knowledge we need to do this. So we're going to figure out problems like this today. So what is the solution of 3 plus the square root of 2x minus 3 equals 8? So one thing, first of all, when you're solving problems like this, you want to make sure you're careful with your radicals. You keep them over the correct numbers and don't put things in there that aren't supposed to be there, and don't take things out of there that aren't supposed to be out of there. It's a notational thing that I see a lot of people make errors with, so make sure you keep track of that. First thing we're going to do to solve this problem is isolate the radical. So we want to get rid of that radical ultimately, so we have to start by getting it alone. So I have 3 plus the square root of 2x minus 3 equals 8. I'm going to subtract 3 from both sides to get that radical alone. I have 2x minus 3 equals 5. Now we know to cancel a square root sign, I'm going to do the inverse or opposite operation. So I'm going to square both sides. So again, I can't just square one side, so I'm going to square both sides. And that cancels the square root on that side, so I'm left with 2x minus 3 equals, and then 5 squared we know is 25. Now I'm going to isolate x. So now this is a problem where we've solved many a time, or similar problems. So solve for x. I'm going to add 3 to both sides and get 2x equals 28. And then I'm going to divide both sides by 2, and I get x equals 14. And that is my answer. So some problems will be pretty straightforward like this. You're just isolating x, which is pretty easy. So or pretty common with what you've done before. Now we're going to do a quick check. 4x plus 1 minus 5 equals 0. So try that one on your own really quick. You're solving it just like before. I'm going to go over it now. So again, you start by isolating the radical. So you have the square root of 4x plus 1 equals 5. To get rid of that radical, you're going to square both sides, and you end up with 4x plus 1 equals 25 again. I'm going to subtract 1 from both sides, and I get 4x equals 24. I divide both sides by 4, and I get x equals 6. So that's my answer for that quick check. Now on to our next example. So not all of them are just going to be square root symbols. Since we've worked with rational exponents, we can have problems that involve those as well. So now we're going to solve one that is 3 times x plus 1 to the 2/3 equals 12. And just so you know, I'm going to go on the second page for the last part of this, but follow along with this first part. So the first thing we're going to do, just kind of like we did up here, we're going to isolate the term or the expression with the rational exponent or the fractional exponent. So here, in order to solve this, I'm going to start by getting it alone. So to do that, I'm going to divide both sides by 3. So I have 3 parentheses x plus 1 to the 2/3 equals 12. I divide both sides by 3, and I get x plus 1 to the 2/3 equals 4. So now this is where we start doing something different. We're to cancel out this exponent. I'm sorry if you can't quite say it, but it's 2/3. To cancel the exponent, I'm going to raise each side to the reciprocal of that fraction. So by doing that, I'm going to create an exponent of 1. So I'm going to write that step down with some detail. So I'm going to raise each side to the reciprocal, that's an I in there, CI, of the rational exponent. So that it becomes 1. So what that will look like, in this case, I'm going to raise x plus 1 to the 2/3. The reciprocal is, again, just the flipped fraction. So it's going to be to the 3/2. And then I have to do that to both sides. So 4 is also going to be raised to the 3/2. Excuse me. Right. So if I can, excuse me. If I continue to simplify that, I get x plus 1 equals 2 times 3 is 6 over 6 equals the square root of 4 cubed. So then if I evaluate the right side and simplify the left, I end up with x plus 1, and this has to be an absolute value, I'll address that in a second, equals the square root of 64. So 4 to the third is 64 when I simplify that. The reason I have to put this in a square root, so step 3, I simplified, and I'm going to put a little star note. In this case, since the original numerator was even, you need to put it in absolute value. So since, again, I was originally to an even power, I need to put it in absolute value. So I end up with x plus 1 equals the square root of 64. Then when I solve that out, I get x plus 1 equals 8, or x plus 1 equals negative 8. And then I solve that out, and I get x equals 7, or x equals negative 9. So those are my two solutions. With these problems, you should always check to make sure that you don't have extraneous solutions, because in some situations you can get numbers that don't actually work. So step 4 is going to be check solutions. So to do that, I plug this into the original, so I have 3 times 7 plus 1 to the 2/3 equals 12. That becomes 3 times 8 to the 2/3 equals 12. 8 to the 2/3 is going to be 8 squared, cube rooted, which is going to be the cube root of 64 equals 12, which, as we know, the cube root of 64 is 4, so I have 3 times 4 equals 12, and that is indeed true. If I try the same thing with negative 9, I have 3 times negative 9 plus 1 to the 2/3 equals 12, which becomes 3 times negative 8 to the 2/3, which also becomes 3 cube root of 64 equals 12, which brings us back to this point, and we know that that's true. So sorry for the tiny notes here. If you can't quite see, that's a 64 in there. If you plug them in your own, you should be able to get the same solution. But if you can't quite see that, make a note and I can show you it when you get to class. All right, so make sure you write down any questions, comments, concerns on this. We'll go over it in class in more detail if necessary. There's one more type of problem I want to go over with you guys. It's when you can have more, or when you have more than one radical. So our last example, I want us to solve for when we have the square root of 2x plus 1 minus a separate square root of x, and that's equal to 1. So if we have two radical signs, these ones can get a little bit messier. So let's go over how to do this. So the first step we're going to do is isolate the more complicated radical. So when I do that, I'm going to have 2x plus 1 is the more complicated one, since there's more than one term under that radical. And I'll move the square root of x to the other side, so I have the square root of x plus 1, or 1 plus the square root of x, either way. So I start by isolating the more complicated variable, and then I'm going to square both sides. So when I do that, on the left side, my square root just cancels. Sorry. On my right side, I have to actually expand this and FOIL. So when I FOIL that out, square root of x times square root of x is square root of x squared, or just x. Then I have plus square root of x plus square root of x, which becomes plus 2 square root of x, and then plus 1 times 1, which is just 1. All right, so now we've simplified this a bit. We can move everything to one side and now isolate the other radical, or the remaining radical, and its coefficient. So when I do that, I'm going to subtract x from both sides. I'm going to subtract 1 from both sides, and I end up with 2x minus x, which is just x. Those ones cancel, that x cancels, and I'm left with just 2 square root of x. Now I need to get rid of that radical sign again, so I'm going to square both sides again. So ultimately, you're going to have to keep squaring the equation until you can get rid of a square root. So I end up with x squared equals 2 squared is 4. Square root of x squared is just x. And so now I have a quadratic. So I'm going to solve this quadratic by first setting equal to 0. So I subtract 4x from both sides and I get x squared minus 4x equals 0. And this is actually factorable. So I'm going to factor out a GCF of x. So I have x times x minus 4 equals 0. So I factor out my GCF of x. And then I use everyone's favorite property, the zero product property. And I get x equals 0 and x minus 4 equals 0. So x equals 0 is one solution and x equals 4 is the other. But as I mentioned before, we always need to check our solutions. So step 8, we're going to check. So I plug these into my original equation and I get the square root of 2 times 0 plus 1 minus the square root of 0 equals 1. And when I do that, I get the square root of 0 plus 1 minus 0 equals 1. Square root of 1 is just 1. So 0 plus 1 is 1. Square root of 1 is 1, so that one works. And then my other one, I have the square root of 2 times 4 plus 1 minus the square root of 4 equals 1. Sorry, I crammed that in a little bit. But 2 times 4 is 8 plus 1 is the square root of 9 minus the square root of 4 equals 1. That's going to be 3 minus 2 equals 1, which is indeed true. So both of these answers work. Neither are extraneous, so those will both be our answers. All right, make sure you write down any questions, comments, or concerns you have on this, and we can go over it together in class.